Hello, am I audible?
Yes, sir.
Okay, yeah, thanks. Okay. Mm, so how is your assignments going on? I think ninth is the last date, right?
I think tomorrow is the
Seventh,
last.
sorry,
Tomorrow.
seventh.
Seventh. Oh, okay. Sorry. Oh, ninth is a webinar. Okay, I got it confused. Okay. Yeah, good. So, so how is the assignment till now? Like many would have already completed, right? Completed, submitted, all those done.
Yes, sir.
So, so how was the assignment? Did you learn anything? So, did you attend my previous classes? Anyone? Whoever has okay, let me be more clear. So, whoever has attended my previous classes, I had mentioned my intention of giving this assignment, right? The way it is, whatever it is good or bad. I'm not interested. My intention is, I hope that's good. So did it serve its purpose or no? That's my first question. You can give a genuine feedback because, of course, it will not be helpful for your batch, but I'll try to improve in the next semester if I am the lead faculty.
So
Hopefully, I
it's
will
a
be.
good
Yeah.
approach, sir. Like it's a different of a kind. And I felt like
Mhm.
my assignment was the paper which was given. I learned a lot
Mm.
from that paper, but I don't know how
Okay.
I
Mm.
presented and all. Regarding the irrespective of the marks, but I felt
Mhm.
very happy that I learned something differently for assignments rather than mugging up and
Okay.
writing some assignments.
Okay. Good. Yeah. Thanks. That's one of the intention is served, I guess. The other one, okay, I'll repeat my intention. So I wanted you to prepare the presentation, right? So as I mentioned, I think in the last class also, I guess I mentioned this. So that's itself an art of preparing a presentation, right? So preparing presentation is very important art. It's not just an art; it's very important art if you are into any place, even if you are an entrepreneur or a developer, a manager, anywhere it's required, right? So it doesn't matter you prepare slides or not. If you are presenting something to somebody, even if it is a slide or a whiteboarding kind of presentation, you should know what to be exactly presented and what to be spelt out so that the others understand in a whether they are the other side also. Other side can be technical, non-technical, maybe your family members itself, or anybody who doesn't understand anything about the technical part. So that's my intention of giving this. But of course, I cannot tell you go and present it to somebody who doesn't know anything. I don't know who, if finding them also is difficult. So fellow colleagues would be like a good option because they would have not read the same paper, right? So that was my intention, that how good you prepare a slides and how good you present it. So it's just one attempt to improve on. Maybe it just improves 0.1 percentage of your overall skills of presentation and the slide preparation skill. So whether it did it serve that purpose or no?
I
Was
I
asking.
uh, I think the one challenge that I saw is with the limited number of slides. Like ultimately, there was 8 slides, and you needed to
Mhm.
fit in the information and then
Right, right.
present. So there is some
Mhm.
background also. I mean, so mine was
Mhm.
related to quantization. So the
Mhm.
paper also has some background, right? So how
Correct.
much you put it there and how much you talk,
Mhm.
and I mean, you kind of assume. So that was
Correct.
interesting. So
Yeah.
yeah, like that.
Okay.
That's
Yeah,
I
yeah.
think
Got
what
your
you are
point.
same
So
point that you are making. I mean,
yes,
how
yes,
you
yeah.
can in that concise way you can give most information.
Yes, no, the most of the information I'll not tell. See, don't always think that other person does not know anything. there's two things in a presentation. What is very important is we one thing is we think that the other person does not know anything, so we have to start from basics. These the people who think like this are complete technical people. Okay. So they always think that the other person does not know anything, or they think that too much technical they know and they proceed with some hi-fi technical words. Both are incorrect. Okay. Second thing is there is an art of knowing what you should deliver to which audience. You cannot go to your CEO and then talk from A to Z. So CEO wants something related to cost, budget, profit, output, goals, deadlines, but maximum that. And even if it depends on how busy he is, so he may be requiring only 2 3 points out of it. But when you're presenting to your fellow colleagues, then it is a different set of slides. So here what we are expecting is in this presentation preparation, we are expecting like you are presenting to a technical guys. Even I hope I am also technical like you guys. So it is to me, if you are presenting to your fellow colleagues, students, you are presenting. So of course you should not start from zero. That's the first point. Second, because you should assume some level, not too much level also, not very less. They know, you consider that they know every subject till second semester. So that's the minimum expectation level you should have while preparing the presentation. So presentation should be whatever they know till second semester, based on that. Don't explain anything which is still there. That's the art, right? So I don't know, maybe I am giving you a tip on, ideally I should not give today. Those who have already done it, or you can revise also. But point is, this is the consideration. So half of your information gets killed here. Okay. So you can make it at a higher level, but not too much higher level that they are not all PhD students, right? So your fellow students, you yourself has fallen into that category, that before this semester, what do you know? So from there, how did you learn? That much, only that gap you should be there in the slides. Not too much detail or not too much less detail also. That's the expectation actually. If I'm wrong here, you can let me know. That's my expectation, because many emails came in say asking that the same question, right? A lot of pages are there. The details are not getting fit into one slide. I also thought about it, but then I didn't wanted to increase the slides because it's too late, right? So we cannot change something in the mid of the assignment because it will affect others also. That's what I think like this. So that's what I think. It's fine having 10 slides in, I think 8 slides ideally. 8 slides should be fine. Ninth slide is in feedback. And one more learning, which I actually forgot last class also to mention. During this one, you have, I don't know, see, many of you would be already using the LLMs, Copilot, GPTs, ChatGPT, and Gemini, other things. But those who did not know, so in fact, I really was shocked to know that many of the people do not know how to use ChatGPT. So it's not like just open and then ask a question that everybody can do. But I'm asking is in a right way. And so as you use more, even I don't know, I have learned it since I have used a lot of times. So I know what to ask to a ChatGPT 5.1 or whatever it is, right? Gemini, what you should ask, how you should ask, right? So those things by practice I have got used. So my prompt to the Gemini will not be same as ChatGPT. That is based on the experience. So what I'm saying is, here in this assignment, you would have 100% used LLM, right? So after you learned, use the LLM to understand how you can prepare the slides, right? So that's also an art, like that's also a learning. I'll not say that's an art, that's a learning. It would have benefited you, because I have specifically mentioned that you can use LLM, like LLM disclosure you can do, so that there is no issues. I just wanted to mention, uh, don't want to mention it explicitly that you use LLM, because that will discourage people who are reading itself line by line, right? So I wanted people to read as well as use LLMs to prepare these slides later. So if they are like confused, okay, how can I consolidate and stuff? So LLM can help. Okay, if you, even if the prompt I told you now, if you take the transcript of this and then feed it to LLM, it will be able to give you a better slide content than if you just read it and prepare a slide content. So what I mentioned is like till whatever you learned till second semester, exactly that same thing you have to put it to the chat GPT, right? Or chat GPT or Gemini, and then tell, okay, till second semester, I have learned these papers, these topics related to the paper. If you put that sufficient, you don't need to describe every course, every subject topics, but related to the paper, these are all things we already know. So currently, in a course, I am reading about this paper. So what should be the learning from this particular LLM? So just in a random way, I just mentioned this. This should help you understand how less content could have satisfied that slides. Okay. I hope I made sense. I just wanted to give us a hint. Okay. Any other feedback you feel? Any other improvements you think, sir, as a Karlo, like this would have been little more better when you felt? Don't think to make it easy. Think in the perspective of making students learn. So my intention is like that. I'm not here to make your life easier. No, of course, I'm very sorry if you think like that. You can scold me at the back end, but my life is my satisfaction. Okay, salary is same, but satisfaction comes only when you people will tell that I have learned something out of this, every component of this course, every lecture, every assignment, every quiz is okay, whatever you learn, assignment, mid exam, final exam, every lecture. So keep, if you want to give a feedback, think about in that terms that if you would have added this component, maybe students would have learned it, or it would have added a compulsion for them to learn something in a different way.
Yeah.
Do anybody can
Sir,
think of? Yeah, yeah.
one topic related to assignment itself.
Mm-hmm.
Reading paper itself is an art, right?
Correct.
And that's becoming more required with this field, especially when like every day a new paper is coming. One session, if you can take how to read a paper and how to get the I mean the
Mm-hmm.
content out of it in a meaningful way, because we are all technical people, right? Uh, we, we very few times we read a paper so that
Mm-hmm.
would be helpful, I guess.
Yeah,
And
yeah,
how,
got you,
where
got
also,
you.
what are the sources and how to
Mm-hmm.
read a paper would be helpful.
Mm-hmm. Okay, okay. Yeah, yeah, I got your point. So
Yeah.
uh,
Even a small
consider if time is there, yeah, we
session,
can do that.
yeah, that would.
But I'll share one paper. Actually, there is a paper itself to do that. How to read research papers. There is a research paper on this topic. Actually, this
Oh,
was shared to me when I was doing MTech by one of my prof, Ankur. I don't know. I forgot his Ankur Panchori. I forgot his second name, but his name is Ankur. He took graph analytics, my favorite paper. So he gave a lot of research papers. So in that, the first research paper he gave is how to read a research paper. Okay. So in a crisp way, what I still remember from that paper is you have to read at different levels, like how you are. So first time you have to parse through the paper, even if it is 150 pages, just parse through the paper, understand the very high level. Then next time you go through and then take a fair notes. Okay, a fair, not rough notes. Sorry, not fair notes, rough notes. And once you take the rough notes, complete it, take a break. Okay. I don't know. This is not exactly mentioned in the paper. This is what I follow. So you can, I have merged the papers and my own style here. So second time when you read, take a rough notes of complete stuff, handwritten notes. I always love handwritten notes. And then don't take online, because online you will forget it. When you write it, you'll remember it more. So that's the reason. If you are not habitual of writing, make it. That always helps. Okay, it will never betray you. That's a promise from my side. So second time when you read, take notes by hand. Okay, draw the drawing by hand, and then take a break of 1 day. Don't do the third round that same day. The second day, you go through the notes first, and then if you whatever you will have a lot of questions, right? So you missed something like you read that second day, no, sorry, first day rough notes, and then go to the paper, read it fully, and then take the fair notes. I think that fair notes is like permanent. So nobody remembers any paper, but when you wanted to, you will understand that one liner of the paper only in your mind. Okay. So whenever I wanted to go, I know, okay, there is a paper for doing this. So I have to go back and I don't need to read that paper. I just have to read my fair notes, which I prepared after the third time. So I think this is sufficient, I guess. You can build it up. So and every this is not the right way. So whatever I told, this is not like universal right way. Everybody has their own style, right? So maybe somebody reads it one time, they are very good at it. I am comfortable with this three rounds of reads. Somebody wants 5 rounds, so you have to optimize it for your own style also. Okay, so this is my general like tips what I can give. Hope this helps. Okay,
Yeah, thank
so
you.
yeah. So, okay, so we'll go back to the paper, this one course. So this class will be going through the 4 topics. Okay, the prompt engineering. Then we'll follow
Sir,
up with the,
hello, sir.
yeah.
Yeah, yes, sir. Yes, sir. I mean, sir, I'm sorry to be interrupt, sir. Sir, I mean, actually, I mean, lecture slides, I mean, 5 and 6 are not, uploaded to the Taxila, portal, sir. Like, can you please, load it, sir?
Oh, portal. Okay, okay. Actually, you
Yeah,
can check here in Teams. It will be there.
yeah,
You want the slides, right?
basically yeah, for the other section, students, it will be
Ah, okay, okay. Yeah, yeah, I
useful,
got you.
sir.
I got it. Yeah, sure, sure. Actually, I
Yeah,
always
so,
think that
we see,
other
only
professors will
up
share.
to lecture 4 years are in the portal. So,
Mm-hmm.
but just,
Okay.
I mean, so, and then like in my, in my assignment, there was some reference to lecture 5, contents. So, it will be, better, if someone loads. So, uh,
No, no. My just I wanted to repeat my own question.
yes, sir.
See, for you, if you are in my class,
Yes,
your
sir.
for you the lecture slides are available, right? Is there
I
any
mean,
issue in that?
saying in the, Teams, right, sir? In the Teams,
In the Teams,
files
yeah, in
folder.
the Teams. Yes,
Oh, okay. The annotated slides, right, sir?
correct, correct, correct.
Yeah. Okay,
That's
then, sir. I
available for
think
you,
it should be
right?
fine. Yeah, yeah.
That
Yes,
should
sir.
be
Yes,
fine.
sir.
So
Yeah.
if you are asking
Okay.
for
Oh,
other class students, yes, I completely agree with you that maybe if others professors are like not able to, like they have not uploaded, then I will. So for me, if you see, it will be here. Okay. So till 6, it is already there. Okay. So other professors,
yeah.
if they have not uploaded, then you can see. But mine, our class, you can find the lecture notes here. Okay. After the class only I upload, but it will be just that it will have that what do you call this annotations, right?
100 is. Yeah.
Not with me.
Okay,
No
sir.
problem. Okay. You understood,
Yeah.
right?
Thank you.
So,
Yeah, yeah.
okay,
Yes,
if
sir. Got it.
one more thing also for you guys, it will be required the other one, but you cannot take printout of that, right? So, because you are not allowed to take for the mid exam. Mid exam
Yeah,
is
yeah.
the
Right.
memorization, right? Okay.
Yes, sir. Sir.
Okay.
Yeah.
So that issue of like getting it without annotation is for the main exam because wherein you have to take prints, but that you will always get at the last.
Yeah.
Some five,
Yes.
6 days before you will get that you have to anyway think of printing at that time. Okay.
Yes. Yes.
So now
Yeah.
coming
Okay, sir.
back,
Thank you.
yeah, yeah,
Yeah.
yeah, yeah. So your question is answered. Yeah.
Yes.
So now coming back to the subject, first one is the prompt engineering. Second, we'll go through the instruction tuning. Prompt engineering is nothing but you have the LLM, you can start prompting to it and then get a response. Okay, that's simple, right? So whatever is LLM's knowledge, which we always call that pre-trained data, which is getting ingested, imbibed into this structure, architecture of the LLM, that's the knowledge it has. So whenever you prompt, it will give you an answer. Okay. So now point is the pre-trained LLM, PLM, we call it as PLM. Okay. So this is your skeleton LLM. Okay. So when you put in pre-trained data, so and you do a very robust training, right? So when you do, you will get PLM. Okay. So we call it as, it's not LLM. It's everything is LLM, but this is pre-trained language model. Okay, so pre-trained language model is, you can call it as a just a skeleton. You can say architecture. Okay, so architecture may be decoder only architecture. Okay. So you put a pre-training data and then you get a PLM, pre-trained data. So here itself you can do prompt engineering. Okay, so you ask a question, it is going to give you output. So what it is going to give you output is, it is the next word predictor. So this is going to next word or next token predictor. Okay, so the best possible word will be the output. Okay, so now what you have to do further is you have to do the instruction training, instruction tuning. Means you want it to obey some instructions. Like, so when you ask a question, you have to have an answer, right? So, but this model will not give you a response for a question. This model, what it does is it will predict the next word of your question. So you ask a question like, what is the capital of India? It will tell New Delhi, but point is, it doesn't know that that's an answer. It is just that after that, whatever is the answer is, whatever is the word is new and next word is Delhi. That's how it answers. Maybe in all its pre-training data, it has seen it like, what is the capital of India? And followed by an word answer like this, right? So this is the query, what's the capital of India? And then obviously like this answer will be there, right? So answer and then New Delhi. So if this would have been your pre-trained data everywhere, like this is the question. Suppose you consider that all your pre-training data was like a FAQ, right? FAQ documents. So it's like a question where you ask what is the capital of India. So India, correct? India, and answer is New Delhi. So this is the data which you have used for pre-trained data, like millions of data, right? Points. So then when you while prompting that PLM, if you would have asked what is the capital of India, the answer also will start from here. It will say answer hyphen New Delhi. So it is not following instruction. Like you are asking a question, answer is New Delhi, but it will not give you that exact answer. Okay, it will give you the next possible uh, next word, the possible best possible word there. So in its pre-trained data, it always saw after India, it always saw answer, right? So this will be part of its answer. So that's what is PLM. Okay. So during instruction training is where you tell that, okay, this is a question. So even though the user tells only this part, this is a question, and the answer is not all these extra words. It is like New Delhi. This is the answer. So this is what is being taught here. Okay. So with few examples you can teach. There is a paper, we'll discuss that. That's self-instruct framework. I think GPT, sorry, OpenAI used that paper. Okay. To initially, if you would have gone through, right? So it will be instruct GPT. Uh, GPT is the first model which came as the chat GPT model. So once you do this instruction tuning, then only that LLM. So this LLM, now you call it as an LLM. This is your instruction tuning. Not fully right. Instruction tuning. Okay. So now this LLM is worth to be deployed for a chatbot. This is not worth to be deployed for a chatbot. This only does an expert predictor. This will be worth for deploying for a chatbot. Okay, at the back end. So this is the first. Second, next part what we will see is reinforcement learning, right? The third part, sorry. Third part, reinforcement learning. Reinforcement learning is little bit more like you are enhancing the um model to think in a particular, what do you say, way. Okay, so you can imbibe some thought process, right? Direction. So reinforcement learning is more like thinking. Okay, you are imbibing thinking into the model. So now you have imbibed instruction, question and answer format into the model. Now another one you can do is RL, which can be like thinking. You can imbibe thinking into the model. Okay. So however robust you want, you can make it. This is same LLM only, but RL field, RL fine tune. Okay, there are different methods to fine tune that way. You can think like thinking, but it's not like what you think is like detailed thinking. No, it depends on how good you are, how what is your input in a way you are using it for reinforcement learning. Okay, but in main concept of reinforcement learning is to be remembered is that you should not tune it like okay, so instruction tuning, the difference between this and this, not only just thinking, the main technical difference is instruction tuning, you do not have a control. Okay, it's not a controlled environment. So if your instructions are like biased on something, the LLM also, PLM will get tuned into LLM in a very biased way. Okay. But in RL, you are trying to keep up, retain that model into its original form, right? So from here to here, we are not changing many things. We are just changing how it should think only. Okay. Like to be frank, like I'll tell you here. So suppose when your PLM is here, this is your PLM. Okay. So once you fine tuned, it moved to some, sorry, to this location. So this is your LLM instruction tuned. Okay. Now this is your place of how it is going to answer. Okay. So now RL, how will you tune on this? Or sometimes directly on PLM itself, they tune RL. Okay. So that is also there. But what I'm trying to say here is when you are doing the training of reinforcement learning, okay. So you have a controlled environment like this. We will see it in formula. Your model can move till here only. It cannot go outside this, whichever direction it can go, but based on the input whatever you give, but it cannot go out of this limit, because if it goes out of this limit, what happens is it forgets the previously learnt knowledge. So here pre-trained knowledge is a very important knowledge, correct? So you wanted it to remember, like for example, you have learnt English all of your from LKG till graduation, right? The bachelor degree. But in PG, I am not telling you to like you are supposed to learn some specialization in PG, right? So, but it should not be so specialized that you forget a lot of knowledge what you learned in your physics, chemistry. Maybe it is not related to AML, but you should not like forget that knowledge, right? That is also useful in your life. So that is why we are having a controlled learning. Okay, but it learns the thinking power. So two things, it learns thinking power, but it is limited by some original knowledge. You should say original knowledge. Okay, so that's the point here. Fourth one is the instruction tuning. So you wanted to tune it based on your domain knowledge, right? So domain terms you wanted it to learn. So that's where you will do this. Okay, so this is also very huge, but you can do it with less number of samples also. But this is also like you need some 3,000, 4,000 samples. Even that is considered less compared to the pre-training data what we have used. So the data keeps on reducing. Okay, for fine tuning, you can use 100 samples also. Still, it is okay to fine tune that. But again, whenever you do fine tuning, it's always to limit the learning curve, because the learning what it has done during pre-training, which is millions and millions of documents, that original has to be kept. You cannot just pull it out of that comfort zone. Okay, so you have to direct it to some uh, 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 domain, or direct it to some style. Okay, style is different, domain is different. That's all fine, but original character will remain same. Okay, it should remain same, because when you make it too much away, it will neither perform good in your domain nor in its own original pre-trained data. Okay, that is why you should limit it. So if you feel, that is why I always told you in starting also, that you should never take a if you get a pre-trained model in your domain, that is the best model you can do a fine tuning. So see which model, like for example, you wanted to fine tune a model for coding, and that to Python coding. Okay, so think of pre-train whichever model is pre-trained data, more pre-trained data on Python coding. Okay, you cannot simply pull any coding lang PLM and then tune it for Python coding. Okay, so that's the point, because you cannot pull a C++ expert and then make a complete Python expert, right? But it already knows a lot of Python. Maybe it's incorrect Python also. It has learned everything. Okay, to make it more optimized, production grade quality, you just have to fine tune. So that's like your MTech. MTech is just your fine tuning, right? So you don't like, you should not forget the prior knowledge, but you are just going towards a specific domain in a very concentrated and whatever you can say that, right? So narrowed down direction. Okay. So these four things we'll see. Okay. So most of this we have already seen, but technically we'll go through these slides and then see. Okay. So any questions here? I hope I was clear then, right? Okay.
Does it go all hands in hands, or like it can like individually also these can be applied, or it needs to be applied all together?
No, no, it is not mandatory that you have to see all these three can be applied separately also, but PLM is mandatory. Okay, PLM is the main pre-trained data, right? So pre-training has to be done. Instructing with, that's what I told you, this line, the top line I told you, you without instructing tuning, you can directly do the RL train. You saw this, right?
Yeah,
In
yeah.
the top line, this line. So directly you can do RL training. Okay. So and fine tuning also you can do directly. So it is not like it is impossible. You can do that. See, idea, if you go in deep, fine tuning is like instruction tuning is almost same as fine tuning. See, this is actually same as fine tuning only. This is parametric efficient fine tuning. So instruction tuning is like SFT, supervised fine tuning. This is also supervised fine tuning. All are same. Okay. So instruction tuning and parametric efficient fine tuning is simply that you are reducing the parameters which it has to learn. You are taking the complete model, and there are many weights, right? So in your deep learning also to learn, lot of weights will be there. Like if you see, that's what we call as billion parameters, right? So in LLM you have 7 billion parameters, correct? So in SFT it is considered that you tune everything. Okay. In parameter efficient fine tuning, there are different ways that we will see. I'll not say you don't fine tune everything or you have to fine tune only 1 billion. There are different ways. There are a selected number of parameters you fine tune. That's one way. There's other ways. There are some differences. We'll see that. Okay. That is the main part of this parameter efficient. So ideally this and this are same. And then reinforcement learning is a separate way. this is like imbibing intelligence, you can say, in a more uh, like automated way. Also, you can do it. That is what we will see that in that this one slides. Okay. Okay. Coming to the prompt engineering. So here, I wanted to ask one thing here, which is not in the slide, because these are all things you can read it yourself. So one thing which is like not today, it came, I think, a year ago, I guess. So there is something called context engineering. Has anyone heard about it or already using it? Somebody wants to share something?
We've heard of, I'm not, I don't know details in detail, but I've heard about it. It's the next level to prompt engineering where you have to maintain the context of the whole conversation or the uh, uh, through either through like markdown files where you keep on updating the markdown file with the like say if you are doing a coding in coding you keep on updating the code, right? And those instructions
Mhm.
go to the markdown file. That way you can keep the context of the entire thing, so that it doesn't forget the main points. uh,
Mhm.
that's
Very
one
good.
way. I mean, there should be other ways as
Yes, yes, yes. Yeah, you're right. So point is prompt engineering is like your goal is like optimizing a single input output pair. Okay, so you are asking a query to a LLM, and then it gives a response. So you optimize how you ask that. That's what we call as prompt, right? So you structure it in a way to get a good response, the or good response, or the way you wanted the response, right? Context engineering is something like it is designing a system, okay, that maintains the consistency in that chats, like it's like a chatbot, right? So for chatbot, it is not a prompting, like it is a prompting, as our friend said also. It is prompt engineering is one part of context engineering. Context engineering is you have to maintain the context between two different prompts, like you, because LLMs are not like it will remember, right? So it's a chat GPT, what you see, it remembers the previous context. So you ask a query here. uh, um, lose my- so you ask a query here. Okay, let me try it here. So you ask a query here. Oops. Ask a query here, query one, and you give a response here, right? This is the LLM's response, right? So it goes to LLM and then it gives a response, right? So this is what is goes inside and it is. So second time you ask a query, this LLM, it is same LLM, but it doesn't know what is query one or response one. Okay. So to manage, so to make this LLM know what is query one and R1, ideally, see, if you send it like this, it is independent. Okay, so query two is a separate independent query. LLM will take and then give a response to. But this response will not have any impact because of this or this. So what our friend was saying was that how will you make, but your questions to chat GPT, you see, you don't ask a query, a separate query, right? So you ask if this is like, what is the capital of India? Okay, so if this is the query and it said New Delhi, okay, this is the query answer. So in the next query, you ask, okay, what's its population? So if I send this query to LLM, it will not even understand what is this query, right? Until and otherwise you give this context along with this context. So to this LLM, what you should give? You should give query one, answer one, and then query two. We have to give all these three, right? This is called context management. Okay. So you should, so, and there are difficulties in this also. You cannot give everything as it is, because if this is a very small query and this is a very small answer. What if this query itself was 2000 tokens? Like how we give books, right? So we feed a book into, we feed a paper, research paper into Gemini, and then tell it to summarize. So summary will be like another 2000 tokens, correct? And your next query is like another book. So consider that is 5000 tokens, correct? So now if you see to this LLM, so to this LLM, you gave only 2000 tokens because this is query one. But for this LLM, you have to give 2000 plus 2000 plus 5000. That is the 9000 tokens. This is still less, but you just to make it complicated, let us add to 10 here, 10 here, 10. Okay. So this is like 20,000 tokens in your book, and your answer was 20,000 tokens, and your next book was 50,000 tokens. So it's around 90,000 tokens you are giving to this. Okay. So which is huge. So as you remember, our time complexity is n square. It will take more time also to respond, right? You would have noticed that bigger the book or more number of books, it will take more time, correct? So, and also it will start hallucinating. So maybe your query, so maybe you fed one book, but at the end you are just asking one query. Okay, the answer for the population is in the book which I shared. So 50,000 tokens, just two tokens it has to bring, or one token, maybe 1 million or 3 crores, I guess, whatever it is. So only two tokens it has to pick up from this 50,000 plus 20,000 plus 20,000 tokens, right? So you don't need to feed every all 90,000 tokens. There are ways to reduce this earlier query and response tokens. So there are ways to reduce. It is graph ways there. There's one project one of my student did 2 semesters before. It was awesome stuff. So I guess he would have published a paper also on that. That was a very good one. Graph, using graph, he did a context compression or reduction, you can call it. And there is other ways also, vector DBs, DBV. Okay, so you can reduce this Q1 R1, and same way now R2 will come. So again Q3 will come. So now you feed in another one book, which is again 50,000 tokens, right? So now your LLM will not even have that much context window to feed all questions, right? So you have to feed query one, R1, query two, response two, and query three. So these many things you have to feed into LLM. Then only it will give a logical R4, right? So how will you reduce this content so that uh, it reduces to some 10,000 tokens only? Okay. So of course it will increase based on how much ever it the earlier ones are there. But you wanted to reduce this earlier context so that this current context is fully available for LLM to answer this R. Okay. So that is context engineering. Okay. This is very important because all this context engineering and stuff only is being done by RAG process, right? And then real-time data, right? RAG is like old data, real-time data also you can fetch it using RAG, right? And there is a state management. State management is the history. So two things you have to feed. This is what I was talking about. This one is the history part. Okay, history part of this particular session, right? The session started with query one and LLM gave R1. Next query to R2, right? This is the session. So session has Q1, R1, Q2, R2, right? So now your question is Q3, so it should give, so sorry, this is 3, right? Sorry. It should give R3. This is your answer, right? This is one is the session management, another one is the rack system. So rack system is like it always feeds some additional. So this goes to LLM, query comes here, RAG will come here, and this will reply. RAG means additional data from your database. So whatever is your database, S3, Blob, okay, Azure Blob, and this is like RDS, right? RDS, or here you, what is this called? SQLDB, whatever it is, right? So any database, you pull in the data from there and then send only the relevant data. Only the relevant data you send it to the LLM. So that is how you maintain the context window as well as make it faster. So it's not like that it has a very big context window means you feed everything. So if you feed everything, it will take that much time because of time complexity and square, right? So you should feed only what is required, right? So that's how it will give a good answer. So next time when it comes, this time it will feed this plus these two, query one plus R1 plus this rag. So this time it has to give R2 based on query one, R1, rag 2, rag 2 you can call, this is rag 1, okay, and then this is query 2, right? So query 2, Q2, R1, rag 2. All these it has to consider and give. So here it will again increase more, right? This is called session management, okay. Sorry, context management, sorry. Sorry, I spelled it. Okay. So point is that how much you have to give and how you can reduce. It all depends on your use case. Telling everything here, sitting here, it looks like it's very easy for me, but doing it for a particular domain, it's really difficult. Okay. So you have to understand the documents at the back end and delete some code. You have to write it on your own also, like customized code. There is no rag which is readily available, pull and plug. If there is something pull and plug, it is not going to work for use case. It's all just lies. Okay, there is nothing. If you say that is for POCs, it's fine, but when you are really going and deploying it in a production, there is no ready-made rag system session management available. If somebody says that, just that you are making yourself fool, right? So you have to do lot of fine tuning here based on the particular logics. You have to imbibe lot of logics here, filtering based on your document system, how your users are like. It is like giving presentation, right? So presentation is not like uh, anybody in the world can prepare a presentation, right? So no, you should first understand the audience. If you did not understand audience, you are already out of the 50% at loss. First, you should understand the audience, at least guess out who the audience is and what will be their level of knowledge, and then start preparing the same way. It should be like this. So who is the users? What are all the documents at the back end? Based on that, you design the session rag and the code, how you give it, filter it to before you giving to LLM. So that is how you do the actual context engineering. That's why it's not possible to do a very generic search. Okay. So, okay. Okay. Coming back here, let's move back. We are not even started. But it's very quick. You understand that it's very easy. Okay. So prompt structure. So priming, right? So you can read and learn. I hate all these things, but still, okay. Assigning a persona. Okay. So you are telling the LLM whom it should be. Like we were talking about this slide, right? So in the first query, the first query, what you are giving to LLM, the user is giving what is the capital of India. Okay. Apart from that, there will be a system prompt. So there are two prompts which will go, which is not known to you, but the system prompt will say, answer this query based on your understanding, whatever it is. Okay. So there you can write what are all the rules and regulations you want to, it has to follow before it answers these questions, right? Okay. Those things. That is one thing. Second thing is that priming means for the given context, for a given prompt, you wanted to review this content or you wanted to, what do you say, answer this query, right? What is this? So that is you review means this LLM becomes a reviewer. Validate means this LLM becomes a validator. Okay, it's like that. So it knows good English. Okay, so only thing is you have to tell them, okay, now you act like a reviewer and review the given paragraph, something like that. That is called assigning a persona. Okay, you are telling it to behave like a, like for example, we behave like, right? So in home we behave like a, with wife, your husband. For daughter, you are a father, right? So everywhere you change your persona, right? So office, you are a manager, whatever it is. So that is the priming. You have to tell it, but you're the same person, the same LLM. When you're saying that, okay, in office you have to behave like this. In office, I cannot play like I'm talking to my daughter, right? So that's the point. So you are telling it, and then it will understand that, and then behave like that's the point here. And style and tone, again, you can give more clear instructions apart from giving a persona. So because again, father can be different types, right? So that is where styles. So you're a strict father, you can be a professional, like very serious father, like that. So that's the style and tone you wanted to give more details about how you should reply. Error handling. Suppose I do not know the answer, right? So what should be? I mean here is LLM, right? So what should be its reply? If the given question, it doesn't know answer, right? So it would have never been trained on what is the capital of India. So what should say? It should politely decline, right? So that's how it should say. This is general terms. Never go by what is written here. You should always think for your use case what your user requires to know, right? Get the answer. If there is an not possible, the LLM does not know to answer it. And fourth one is the content. This is the major thing which got developed to the context engineering. That's what we are talking about, right? So till now, what we discussed was this part, the fourth one. Okay, that is why I told it will be useful what we discussed earlier. So here content is the static. So earlier this was like 3, 4 semesters. I am teaching the same thing. But if you see, this is what got developed. And context is just a new term, but everything was already there. Okay. So static is what I was calling it as a prompt, which is always there. Like for every LLM, let me draw here. Uh, so this is your, oops, this is your query one, which gives R1, right? So this is your LLM. So then query 2 gives your R2. Query 3 gives your R4, right? Sorry, oh, R3 never comes. So, okay, LLM. Okay. So apart from query, what all you add? You add a system prompt. So system prompt only has these things: priming, style, tone, error handling. So these things should most probably will be common. So I will not again say don't take it as a uh, rule. Okay. You can always change that. Okay. So always change means you can do this also as a dynamic based on the user query. You are expecting different types of user queries at different instances. This query is different from this query, and you want an error of this to be different from error of this. Okay. So in that case, what you do, you have to add a dynamic data. Dynamic data. Dynamic data means based on this query, you go to some database. You have some database. You when your system gets the query, you go to this database, check whatever way you can have. Either you can have it in a graphical form. Okay. So graphical form, something like this, graph database, or you can have a RDS, right? Or you can have a vector database, right? So vector database you can have, or simple structural relationship database, RDS, or some SQLDB, right? So you can go to any place in whatever way you want to search, get the data that is called dynamic data, and then feed it. So now for this particular query, you know how to give an error. So you are just teaching. Okay, for this query, this is the query. Okay, so your input to the LLM will be something like this. This is your query, blah blah blah, something like this. Okay, under the quotes. Second one is your what is that? Your system prompt, right? So this is not exactly like this, but I will for your general understanding, this is fine. System prompt. System prompt is the assign what is the character. You have to be an question answer guide, right? So you have to answer the question which is given as the query. So that's the point. So assigning tone and other things. This is your dynamic data. Dynamic data. In this, you are saying that, okay, so you have a further nested JSON in which you are saying that error handling. Okay, just for an example, I'm writing. Okay, so now this data is dynamic. So this data comes from, maybe I call it as data one. So this data is this data one. So you are searching your database where you have stored, okay, different type of queries. You have to give different type of error. Okay, so this is your prompt. So from here to here, from here to here is your input to your this LLM, and it will give you an answer because your error handling keeps dynamically changing. Okay, so I just wanted to make you understand. That's why I put this inside the dynamic content. But you can, if see, from this, what you should understand, two things. First thing is error handling, not error handling. Any data, if it is going to change based on query to query, right? If the data is going to get changed from query to query, then you should keep it under dynamic data. Okay. If it is going to be same, every query, the same data is fine, same input is fine, then you keep it as a system prompt. Okay, that's the point. I wanted to make it here such that it is not, don't follow this always. Okay, this is not a standard way, but this will always be there. But in general, if you see for any query, you have to handle an error, right? It doesn't depend on type of query. But so yes, sorry, that's a wrong statement. For any query, there will be a general error handling logic that you mention here. But your use case requires to handle queries based on its type. That part will go here. Okay. So, and not only the error, which I was discussing here, dynamic data contains lot of other things. That's the RAG, right? So you are giving some 10 documents and telling it to answer a query. So you cannot feed all the 10 documents to your LLM, right? So it's a lot of tokens. It will take a lot of time, right? Latency is the major issue, and cost, right? पैसा भी जाएगा. So what you do, you select the chunks from there. Chunks means paragraphs, you can say paragraphs from there, and then feed it as your dynamic content. So that's the paragraph where whatever way you want to keep graph data, you can keep structured data, you can keep, or vector DB you can keep and search. Only thing is you have to search and then give that particular data. It's as simple as that. GenAI system is very simple. Only thing is, and also one more thing which I already discussed was inside dynamic data, there is a history also. History is another table. So again, history also you can have another graph DB or another structured data or another vector DB. So this may be your documents or history. History means the older queries which the user has asked, right? That is one thing, and the current sessions history, right? So I hope you understand the difference, right? So older chat history means session I'm talking about. Like you started a session, chat session. There was a session one, you asked query one, query response one, you got query two, response two, query three, response three. You closed this chat. Then again, you started a new chat. That is what I'm calling it as session two. So now you ask a query one, it will give a response one, query two, response two, and then you closed here. Okay. So then again, you started a new chat. This is like query one, R1. Now you're asking query two. Now let's talk about this query two. So for query two, these two are the past sessions, right? Chat history, right? So this is no, this is the session history. Means we are in session three, but these two are the session histories, right? And for query two, query one and R1 is the chat history. So for the particular session, the previous queries which are asked is chat history, and for a particular query and for a particular session, the previous sessions, whatever you have asked is the session history. Okay, so understand these terms. You can always call it in a different way, but this is what I feel I am comfortable with. Okay, so session we call So we call it as this one. Some people call this also chat history. Okay. And this one they call it as a current chat history. Okay. So these two they call it as current chat history, and this they call it as a chat history. Basically, you should understand that there are two types of history. One is that the older chat conversation. This is the complete conversation. This is the complete conversation. That is older one. Another one is the current chat. Okay, these two things you should understand. And that also you cannot feed everything into this. So I call that from chat, you have to again feed data to, right? So for the first query, this data to will have only the session history, right? Because this is the first query. For this session, this is the first query. There is no session history. But for this LLM, you will have the data one, which is your RAG data, which is coming from your database. Second one, you will have the session history, right? That is your data two. Third one is your current chat history, correct? So that is your data three. So all these, if you give only, you can get a perfectly understandable, uh, like relatable response. Okay. If you miss something, then you will get, like, if you don't give any of this, whatever LLM's memory may have, or so whatever is there inside the memory of LLM, only with that it will answer this query. If you give the chat history, based on your chat history, these two, query one and query R2, it will give you that answer. But suppose, for example, in this query, I asked about uh, uh, how to celebrate my birthday, which is tomorrow. Okay. So now by the response of this, if I will summarize this chat at the end, okay, I create a summary of here and store it in my session history. So in this, what I could have understood about Bhagath. So Bhagath is the person who has chatted. So he will know that, okay, some date, I do not write my date, but you say, okay, particular date is my birthday. So it knows there are some key terms which are captured from this session and kept. You don't pass all these things to as data to here. Okay. Data to, even though it says session history, you summarize this and capture the important terms and points, like your team's meeting, right? In office, you have thousands of meetings. When I joined a new company, they were saying that, oh, okay, you have to go through all the meetings. I didn't even go through all the meetings. I just taken all the summary of the meetings and put it in ChatGPT and got one more summary out of that. I just read that. So that is the maximum I could do. Otherwise, it will save a lot of, it will take a lot of time, right? So that's all. You take a summary and then prepare a graph of it. That's the most right way, but you can always put in database or whatever it is. Okay. So when you take a summary, even though I never mentioned in this query, so specifically I told that question like that. If you remember, what was my question here was, uh, how should I celebrate my birthday today? I never mentioned to the chat bot that it today is a particular day, right? But in your summary, it knows, okay, today's date in India is this one, so it is his birthday. That is called a very good summary. If you can understand this concept, you have already cracked the chatbot. Okay. So those are the information you have to store in your session history for very far away sessions, right? So this session I had it 2 months before. Okay. So I have to store only very important event. Even a human will not understand, right? So maybe there are humans who can fight with you to ask, remember each and every events which happened earlier. But but if you consider a normal human being like me, or maybe average human being like me, I will remember only which are very important points, like date of birth or something like that, which hurt me or which made me very happy, or which was very unique, surprised me. Only those. And what are all the facts which I could get it, right? So those facts I will store it here. Okay. So that's the point you have to store here, and that becomes your session history. And now in this point, I'm asking that, okay, I wanted to celebrate my friend's birthday in the same way I did celebrate my birthday. So this is my question here. which is after 2 months. But if your chatbot is very intelligent, can get that information that, okay, he's talking about his own birthday. Okay, let me go to some session is there, because your GraphDB will take you very fast to session one and find that, okay, you asked a lot of questions and finally we freezed an answer how you will celebrate the birthday. Same thing, it will pull into the data two as the this LLM question, and then it will give you exactly same thing with little bit modification personalized for your friend, right? So it looks awesome, right? So when you build this is awesome, and this is what your ChatGPT does also, and that's why ChatGPT or Gemini also does it, right? So that's what is required from you guys to build at the end of this course. Okay, I hope you understand this concept. So if you understand this concept, many of the current coding agents will build it. Only thing is you have to tell ऐसे build करो करके, समझ गया? So nowadays, even today, I was working on a project. I didn't write one line of code. It's a huge project, almost 5,000 lines of code, I can say, minimum. But I didn't write one line of code. But I have to tell, okay, you have to take a summary, understanding from this session. But what we normally do, just feed this into um, in keep this into the session history. No. So these are all very small things. I don't say that I'm very intelligent. These are very small things you should understand. Think like a layman, think like a human. That's what I always tell my team members also. Think like a human. LLM is nothing but as a person, right? So you just learned something from pre-training data and came up. So you have to tell what to do, what not to do in the right way, in the minimal possible way, so in a clear language. It's as simple as how will you give that clear language is what is you're doing a summarize. Okay. So whatever, I try my best to cover that part. Okay. So coming back to this, and this is the final output formatting, right? So we discussed this a lot on the structured function calls, right? So that's what it is. So these are all some slides. I don't want to go through detail. I have already explained, I think, quite in detail.
Sir, one
Yes, I just,
question.
yeah.
So if we go to Chat GPT or something, right? There's a scroll bar and all. So will that be
Mhm.
considered as a chat history or uh,
Scroll
like?
bar. What is that?
So if you
Scroll
go
bar.
to
Uh,
Chat GPT or any of the Copilot and all, right?
mhm,
Or any like Teams chat, right? There is a scroll bar on
mhm.
the right side where we see all the chat history. So that
That
chat
is
history
called the
will
session
remain.
history. Session history. That's what
Okay,
I
and
called as session history.
okay. And in what in that what will be considered as chat history there? In that scroll.
You go and click there, you will understand what is there inside it. Have you clicked it? Have you clicked one of them? You will know now what is there inside that. It will not show you the summary. Summary is what you will keep it as a session history. You will not keep the complete. See, you will keep the session history for showing to the user. But for retrieving for a particular LLM understanding, you will save your summary. Am I clear here?
Yeah, understood, sir. Yeah.
Right? Okay. So that's the point. Okay. So we'll delete all those things. Okay. Okay. So going back. Okay. These are all some of the. Okay. So this is one important points. Oh my God! Already 1 hour now. So zero shot prompting is nothing but just asking the query. Okay. So few shot prompting means you are giving some similar examples. So again, these examples can also become dynamic. So if you understood already what I taught as dynamic, you will understand this point what I'm saying. Okay, I don't want to again go back, but if you didn't understand, ask me again. Okay, so few shot prompting can be static as well as dynamic. Okay, that's the only point I want to say here. Chain of thoughts is nothing but you're telling a way to work on it. Like, so you are giving a question, I'm telling it to answer in a way. So if this is the question, right? This is your question. So answer should be like this. You should think like this. So when you teach your kid, what do? You do like that, right? So you tell them, don't become afraid of the question, right? So you have to break the question into smaller parts, subpoints, right? So in I think ML optimization, we do that, right? So in any of the optimization problems, even in your, I think, algorithm optimization, what is that called as a linear optimization or optimization engineering itself has a very good stuff, right? So only thing what they do it in a different ways is breaking a problem into a smaller problem. Exactly, we are doing that. Okay. So step by step proceed karo. If you just simply give a question and ask an answer, maybe it will be wrong. But if you tell it, okay, you work out this, you work out that, you if you do not understand this number, expand it to English word, right? So you can give whatever thing to make it more clear, right? So one by one, step by step, to at the end, you have to give the last line is something which it should be able to easily answer the final requirement. Okay. So this is the way you have to prepare the steps. Preparing the steps itself is an art, right? So and then finally you will give the question. So this is your prompt. Okay. So this is your prompt coming from the user. So this is your question and answer. Okay. So this is your question and answer. You wanted LLM to answer this question similar way. Okay. In the above, whatever way it is defined above. Okay. So then now you are telling your user has given a question, you give the answer. So now your the user question will be broken down similar to whatever it has done, broken down or step by step answer. So it will answer in 4 lines. That's called chain of thoughts. Okay. Chain of thoughts, as simple as that. From the word itself, you should be able to understand. Next is the tree of thoughts. Okay. So tree of thought, there are two ways. Best way I'll tell you. Best way is like one example. I don't know whether example is here or not. So, for example, you wanted to take a decision, right? So, whichever I thought of recently, I do prompting like this. I always like this tree of thought prompting. It's not a big deal. Just that I tell it to think like that. Um, what was that last time I asked was, hmm, okay. Hmm. What I asked, I think about the car insurance. Okay, car insurance to Google. Gemini I asked. So I normally use Gemini. So what I ask is, I didn't ask which is the best car insurance in for my car. Okay. So what I did was, uh, first I wrote it in a detailed way. Okay. So I have to I didn't even write the first line like that. I first line itself started with, get me all the insurances which are available in Bangalore. Okay. Bengaluru. And start gathering the informations of each of the insurance related to these attributes, and then prepare a table, and then start analyzing each of the insurances, okay, in a detailed way, and then provide an answer, which is the best insurance possible. So it's like you are not asking it to give the final answer starting. You are telling it to explore at least whatever it is. I didn't give three. I told every insurance possible from I think I told top 10 insurances based on different websites. That's what I told it. So it's like something like that I told, and then it took a lot of data. It collected all the data, tabulated it, and then using those data. So one thing what you have to understand here is, when LLM has tabulated, right? So that becomes an input for the LLM for the analysis. So that is why you should do like that. So point is, so you are asking a query here, right? So your query says first step is to get, suppose, top 10 insurances. Okay, just understand again. Second one is tablet uh, details about them. Okay, so this is the second. So third step, you are saying analyze from uh, a common man's perspective. Common man's perspective, you can write, or a particular car model and age of the car, all those things you can give. What is your persona? So that is what you are telling, and then analyze from that perspective, and then provide an final answer. Okay, final answer with reason. Okay, so why it was. So this the only I will only read this part. Okay, why these first three steps is like you have this is my prompt. Okay, this is my complete prompt. So what LLM does is it will first gather these top 10 insurances. So when it gathers and then lists them, now what happens is this, so when the LLM gathers these information, right? The only input for that is this one plus some internet resources, right? Internet, it went to internet and searched for it and then got this 10. Okay. So this is the first step it has completed. It will continue to the second step. Okay. But point at the second step, what is this is? So the same LLM is going to continue with that. It is not going to stop and ask. Okay. So it's continuing. But point is the LLM what we are using, if you see, this data goes inside this prompt, the complete question. This data is coming from here. Apart from that, this data is also there. Now the second step, tabulate details about them. So it has this 10 details. And now it is going to go and search internet about these 10 details and going to build a date table. So for you explicitly what you see is not what happens inside LLM. That's what I'm trying to say here. So what you see is the complete answer LLM gave. What you see in your on your screen. No, as it ended here, this information is an input for this to produce this input. Sorry, this information is an input for this to produce this output. Okay, sorry, I told input output wrongly. Okay, so that's the point. So now point is the third step, analyze. So how will you analyze? It doesn't go to, it doesn't take only this one and then internet and then analyzes. No, it takes this as input and then analyzes. Okay, so now it has a very clear-cut clarity of the data which has already been collected using some hardware, right? So there is a hard work at this point, right? So that it doesn't need to do that hard work at this point. But for you in your screen, it is all a single answer. Same thing for the fourth answer, right? So this is more dominating dish points for the LLM to decide at this point to create this third answer. Same way, LLM will decide the fourth answer based on 1, 2, 3 internet source and this query. Okay. So I hope you understand, right, how LLM works. LLM works. This is your prompt. You give us input. It will give the next word. Correct. So you say this we have done so many times, but I will just write in a quick way in order to. So this is your prompt words, token numbers from 1 to 10. You feed it to LLM and then it predicts 11th token. Okay. So now next word, how it predicts is from P1 to P11 and then it predicts the P12. So now you see this P11 has already gone into the LLM. But in your same thing, I'll continue this for one more word. So it will produce P13. Okay. But in your screen, in your chat bot, what you gave was uh, prompt token 1 to 10, which you gave to LLM. And what you see in your screen is prompt 11 to prompt 13. You think that, okay, based on this, it has produced all these three words. No, it happens like this. Okay. So when it produces an answer, one token, it goes as an input to your original LLM. This is the original exactly the same LLM. Okay. The same LLM, but it's a new what do you call? Call. Okay, so that's how it works at the back end. Okay, it's not like that you gave 10 words and you gave 3 words. No, you gave 10 words, it produced 11th word. Then it will take 11 words and give 12th word. And you gave 12 words and take 13th word. And it will take the 13th word till 13th word and then produce 14th word. If this 14th word is suppose an end token, okay, this is the word, then it stops here. It doesn't go to the next call. It doesn't take P1 to P14 because this 14 token is an end token. Okay, so end, or it is different type of LLMs have different end token names. Okay, so that is how you get 11 to 13. Okay, so if 14th word is not end token, that also would have come here. Okay, so that's the point. So this same logic, you are using it here. It's not just token. You are using it as a complete information. Okay, so I just go through all these things. So this is automatic prompt engineering is nothing but there are some libraries where you can optimize your prompt also. Okay, so how do you prepare an prompt? Okay, so you have to use some samples, like you give an input, you give an output, and then your prompt engineer means automated prompt engineer, like you have some 10 100 50 examples. So you know the input, you want the output as this, right? So like this, you have 50 samples, you give it to this automatic prompt engineer, it will prepare an optimized prompt. So now once it is prepared, now you will send that to your LLM. Okay, so now your optimized prompt is there. This is your standard prompt. Along with that, your input will be there. So suppose this is 1 to 50 you had. So now you 51th input you will give along with your optimized prompt. Okay. So 51th input along with your optimized prompt. This will provide an output 51th output, which will be more similar to what you asked for in the remaining 50, what you have given it. So that is the logic. Okay. You can build a system like this. That's the point. So that's also one thing, but you will spend some time if you're intelligent enough. No need to build a system. You can also understand it by changing some words and doing. I have never used that kind of automated system, but it is available for you. If you wanted to really go worry about the tokens and things, you can do that. Okay. Oops. Okay, another 40 minutes. Okay. So now coming to the instruction tuning. So this is the instruction tuning. Okay. These two are your RL. Okay, don't confuse things. This is there. Okay, it is written there. So this is the first part is instruction tuning. Second part is RL with from human feedback. But don't think that it is always RL is followed by instruction tuning. You can directly do RL also. Okay. So this is for this paper. Okay, training language models to follow instructions with human feedback. Uh, I think ChatGPT was the this steps ChatGPT used. The first instruct GPT, I think from 3.5, GPT 3.5, they created instruct GPT using this logic. Okay. So what they do here is it's not a big deal. I already told you. So you are giving a question. Okay. So the labeler demonstrates desired output behavior. Okay. So, and then you collect such kind of answers, right? So you have some, like, that's what exactly I told earlier also. You have an input, a human sits and writes an answer, right? The correct response. I call it as CR. Very close. CR. Okay. Correct response. Okay. So like this, the humans maybe prepare some 50 CR 50. So this 50 samples have been for given question. What is the correct answer? So this one 50 samples have been prepared by humans. Okay. So use that to train it. Okay. So that is called as fine tune. Okay. So this is like instruction finding. So how do you want it to answer? That human decides. And if you train with this, then it becomes supervised fine tuning. SFT means supervised fine tuning. Okay. So this is like supervised policy. you train on a demonstration data, so which is human specific. But what is the disadvantage here is the cost, right? The humans are the cost, right? And there are different disadvantages also. Humans can be biased, right? So because you are, if you are telling, okay, maybe 100 people also you call, how much ever you can get, you cannot get variety, right? So you will always miss out something. So there are some different logics to go for the other one. Okay. So now, but you need this, okay, because you need it to learn instructions, because the pre-trained model did not learn to answer instructions correctly, right? So what you do, you will feed some human labeled answers. This is required, okay, but you should not feed more data. That's as I told you, SFT is not the right way, but it is required for to some extent. Some extent it is fine, but if it will cross, because here you are not measuring. You see here, you are not at all measuring anything to. You don't have formulas. You don't have any limitation stops, right? So it's like, okay, I keep on teaching you, I'll brainwash you and make you some bad person, right? So that is the point. What supervised fine tuning is like, I am the boss. I can teach you anything, tell you that Jene is so useless, and then brainwash you. And maybe many people will believe me, right? So if I tell in the right way, in a very convincing way. So that is wrong, right? So there should be some check, right? So that is where we come for this RL. So RL means reinforcement learning. Okay. So what we do here is a prompt and several model outputs are sampled. Okay. So here you give a sample. Okay. So you get some answers. So from the model only you will get this. Okay. So you take up this SFT model is there, right? So here it is not clear. This is the SFT model. So you give this query, the similar kind of queries, and then you tell it to generate different answers. You're telling it to generate different answers, okay, based on temperature, whatever it is, okay. And then now you will tell your labeler, human, to uh, order it. Order it means like the D answer was the best answer. Right? C is little more okay, correct, because all are subjective, right? So there is no correct answer, there is no wrong answer. It just depends on the user. Sorry, evaluator. It A and B are almost same. Okay. So now like this, okay, like this you will do. And now what you do, so again, you should not say that, okay, again, you are using human. No, you are still not coming there. Okay. So using this data. So now for every query, you have this kind of rating, correct? So what you do now, you will use this data to train a reward model. So the reward model will be able to give a score. So you will train this logic. Okay, this is like one. This is like maybe zero. This is zero. This is point. Something like this. You give a score and then tell it to start learning. The reward model will be learned with this data. With this data. Okay. So with this data, and then this reward model will be able to give one score that is called reward. Okay, so reward means when you learn from this model, so in future what this reward model is going to do is, when a new query is given, right, and a particular answer is given, answer once response is given, okay, if you give these two, it will give you a reward. Reward means it will say, okay, this is 0.25, this query and answer, it will give 0.25. So if you give another query and another answer, or even the same query and you give different answer. This is 1 1 and this is suppose 1 2. The same query. This is query 1, this one. So if you give these two to RM, the same RM, okay, the same RM, then it will give 1, maybe 0.9. So it's just that you give a query and you give a response, it will give an answer, rank, reward. That is the point we have trained it. So this is just a train a reward model. Okay. So now comes the original SFT model, which you have already trained. You have used to generate some answers. Now nothing you have done to SFT, right? You have taken, ideally this is also a language model only. Okay, so I don't want to confuse. Think that this is another neural network. Okay, but this is also a language model only. Okay, maybe the same language model or a different language. So I'm confusing you more, but think this is a neural network model as of now. Okay. So till now, we have not done anything to the original SFT model, which we already tuned, right? So now comes that is what we are coming here. What we do, you give a new prompt. Okay. So now you are giving a new prompt. You are giving it to this SFT model. PPO likha hai na, this is what is this SFT. This original SFT model, which you used here to generate some different samples, that is just for generation. Okay. You didn't change anything SFT. But here is what is your SFT model, what you're doing. You are giving a new query, okay, and you're sending it to the SFT model. Forget about PPO. I'll tell you a little later. So SFT model, and then it gives an answer, right? So how it generates an answer? It generates an answer. Till here it is normal, right? So you give a query, it is going to give an answer, right? So now this RM model, which you have trained here, right? So you have trained here, right? So what is this RM model going to do? You are going to give a query and you are going to give an answer response, and it's going to give you a number, right? So now what happens? You generate an answer using this SFT. To this RF model, what you do, you give the query plus this response, correct? So this is your query, which is coming from top, which you gave it to SFT, and this is your response. Now RM, what is your RM come? It should give a score, right? This is the score is going to optimize. So optimize means, so you have told that this is the best, right? What is your RM basic learning logic is, we have told that this is a very good answer to RM. So RM will try to keep this as 1, nearer to 1, and this one as nearer to 0, correct? Like this, it would have got trained, right? So now when a new answer comes in, if RM says, okay, the score is 0.25, what is your duty? You have to improve the score. The complete system has to improve the score. How will you do that? You use this to update the weights of this SFT. Okay, that's how you do the deep learning, right? So I hope you guys learned in second semester, right? So when you get this low score, but you wanted it 1, right? Because that is what is called as this humans tell this answer is 1. But if your this generated answer as on now, maybe this gives 2.25. Ideally, I want it as 1, right? So what I do, I update this model. Now again, I send the same query, right? I'm not saying a same query. There'll be like 1,000 queries, right? So again, the same query if you send, because you have updated the model, now it will generate a different answer, right? So now the query is same, sorry, the answer is different, r hyphen r complement. Okay, so now the answer is different. Now if you send this query and this r complement, this score should be more, right? Because you have updated the model, SFT model, right? So 0.5. Now still it is not nearer to 1. Then again go back and update this model, correct? And then again you send the query and it will generate a new answer, maybe r double dash. Okay, so now the same query and r double dash you send. So luckily, to make my life easier, I just say that at this point it says 1.0. Okay, so it's equivalent to this. Now you don't need to update that, right? So now you go to the next query, right? So this is how you update it using this. But here one thing is missing, which I always mentioned is limiting. Okay, so the limiting is what we will see in the formula. Okay, so you don't need to worry about understanding, remembering any formulas to just to tell you beforehand. Don't become afraid by seeing. Afraid means don't be thinking, अरे यार परेशान कर रहा है इतना बड़ा formula. याद रखना है, right? So you don't need to remember anything, just that you have to understand the intention of a term, right? So as I already mentioned, that will be a part of the question. Okay, I once, if I have told you 5 times, that is by default it's a question there. Okay, that is the tactic I also used when I was in MTech. I watched the lecture videos of the lead professors 10 times, not 10 times, 3 times at least, to get that crux. Okay, what is it he's stressing, right? So whatever he's stressed will surely be a question. That's how I cracked it. So if you listen to me, blah blah blah, but I think I will be like too much useless in that case because I am talking too much out of the syllabus stuff because I think like a very stupid prof make you learn something beyond what is there in the slides. Slides, so anyway, it is there, right? So uh, I always think you should learn beyond getting marks. Marks will help you to go get shortlisted, but काम के लिए तो पढ़ना पड़ेगा, है ना? So that's how I do. Okay, so this is all these things you can go through, right? So this and all I will not tell. Now let's go through the limitations I already told, right? So human return pairs are expensive because of the you have to give money to humans, right? So and mismatch between the LM objectives and the so language model objective and human well, that's what I called as a bias, right? So humans may be biased or humans may be different from what is your LM language model's objective to learn, right? So that always there, right? So that is why it is good to go for the reinforcement learning. So you can learn many things here. Just go through these slides. These are awesome, right? So I'll tell you one thing just to boast myself. Also, you can consider it for your own usefulness also. I had taken so much pain to do these slides, okay? Really, it is useful. I'll tell you, if you learn all these, I think 88 slides, forget about the marks. You are already an AI engineer because it has everything almost. After this, rest of the things are there in the agent, but this is sufficient. Nowadays, you go for any developer interview, these slides of 88 is sufficient. At least till mid-exam, whatever it came, if you just go through, remember each of the points, you are already cracking 30, 40 lakhs. Sorry to give you so much hope. Don't come back who didn't get it. Okay. So that always happens, right? So luck is always there. Doesn't mean I go and attend interviews. I have also failed. It's not like doesn't mean I have failed so many interviews. It happens, right? In fact, I would say many times the interviewer did not know the amount of GNI what I know, but they rejected me. But I will not blame them because they are learning to hire, right? So that's luck. I'll not say it's there. That's my luck that I went to that time interview and there was already not specialists there that they could understand my contribution. It's okay. Next time I can apply those companies and get to even big companies. The funny stuff is big companies rejected because the people who came for interview, I don't want to say anything. I would have interviewed him better than I would have rejected him for coming for the interview. It's not to just boast because they didn't even know the basic stuff. I'm teaching this for the last 3 semesters and they just rejected me because they asked something which is completely irrelevant of the GNA job role what they came for. Okay. Okay. Sorry for putting my personal points here. Hmm. Okay, coming here, reward model training, right? So reward model is what I already explained. So one thing which I wanted to say here, yes, this one. So this is what we saw in that diagram. If you see reward model, this term is that RK, what we saw in the diagram, right? So this is what we wanted to increase because you wanted to maximize this point, right? But what I always told till now from starting of the class is something which you don't wanted to lose from the pre-training data learning, right? So pre-training data, which was used for training the model, that should not be forgotten by the model. That limitation you should keep. That is where the second part of the scale divergence comes in, right? So this is where, that is why this is negative, right? So you are trying to compare this new model, which is learned model. So phi is the learned model. Don't think it's complicated. It's very simple. Okay. If you don't understand, please ask again. Okay. Phi theta is the learned model and phi reference is the original model. So you start at this point. This is phi reference. Okay. So one question you put and then it learns and then it came here. Okay. So this is phi theta 1. Okay. So you don't want this jump to be too much. That's why it is minus beta. So you're comparing this with this and then saying that this should not be too much, right? That is called KL divergence. You just go and read. KL divergence is nothing but it is a distribution. Okay, the distance between two distribution. This is your phi theta and this is your phi reference. Okay, the distribution should not be more. This is that called as KL divergence. Okay, so you can read about it if you are interested to learn about it. But point here is this distance, if you understand in a visualized thing, this distance should not be so much. So we are having a control by giving a negative number. Okay. So in exam, the question will not be like, tell me this formula, sub. Even I don't remember. Okay. If you don't show me this slide, I will not remember. But the ask is this point. Okay. Control the deviation from the reference policy, that is the SFT. SFT model means, so in this cases, or we always consider before RL, we have done the SFT. Okay. So it's not mandatory that you have to do SFT, but you, because this, why it is written as SFT is because it is considered as the starting point for the RL. Okay. So whenever you are tuning, you always move to the next point, but the next point should not be too much far away from the reference point. Okay. So in a control, this is a control parameter, right? So let's assemble. Every mathematical equation has that. And this is the original reward points. Okay. So if I ask you in exam also, if you simply write reward function, maximizing reward function minus control the deviation. I'm a very layman. This you will get 10 out of 10 if I ask this question for 10 out of 10. You don't need to write any of this if you just write this. Okay. So I know I have been in the other side also. Even I am very bad at memorizing. Okay. So don't need to memorize anything. Just remember what is this stuff. And this you should always remember. Okay. This makes you good technically when you go. See, these formulas automatically your Python code will take it. But why do you use this? That is the crux, because when you learn this, whenever you do fine tuning in future, you will think of this. That is very important. Okay, I should not make it learn so much because it will forget the pre-training data knowledge, right? The pre-training knowledge. That's not correct, right? So you don't want your kid to forget what she learned, like ABCD. She should not forget. If you remember, actually in my college, I forgot ABCD. I missed one or two letters, right? That's very bad stuff. Right? So I learned to ABCD again in college. It's the funny part. Okay, so same thing. It should know it's a very bad thing, right? So it's like so now coming to this is the same thing. Okay, you can keep reading everything. All these are same. So this is like one thing is pre-training data. This is not so much important, but you can go and read. Pre-training gradients are there. That also will keep a track apart from the pre-trained weights. This is pre-trained weights. Okay, but this is pre-training. What do you call the pre-training gradients? There is a difference between pre-training gradients and pre-trained weights. Okay, we don't need to worry about this. This is just one slide to for those who aspire to do PhD. Okay, nothing to ask for mid-exam. Okay. Uh, but so if you see as you go, the model sizes are big. You have to take care of the gradients also. But otherwise, PPO is sufficient. Okay. So GPT prompted means these are all simple things. This is the SFT instruction fine tune, and this is your this model. Okay. And limitation of PPO. So limitation of PPO mean what comes is that the need for the reward model, right? So reward model, you have to train them. So as I told you, reward model also, I slightly mentioned, this is also actually as an LLM. You don't go, we tell it as a neural network, you can have a neural network also, but It has to take a query and it has to take an answer and then it has to produce a score, right? So to understand the text and then produce a score, it has to be LLM. LLM or SLM, language model. Forget about LLM. I always call it as LLM. So language model, right? So it should be a language model. So it is itself a very big stuff, right? So training this to get a good score, correct kind of scores, because you have to train lot of samples. Then only this model will be ready to go for the policy training, right? That's the point. So you need a reward model, you need a policy model. Ideally, we use the same language model for this policy model as well as reward model. So in this case, we just trained it as a reward model. And in for policy model, we use the same LM, that is the phi reference, LM as the phi reference, and then you policy train and then make it as phi theta. Okay, so this is what is the fine tuning we do using this RM. LM, the same LM, you train it with this way, like whatever I told you earlier, becomes RM. So you have an RM, you have an phi. Policy means phi ref. Okay, policy. That's it. Don't confuse it. So in fact, first time I was reading this long before, I didn't understand many of the things. I hope I'm making it clear, right? So if you didn't understand, please just even ping me before your exam. Because why I say this is, even though it takes my time, you will learn something, because during exam only most of you study. If even that time, if you study without understanding, just ratta maar ke aa gaya, so you will never in your life study back, right? But if you study and understand it, you will always feel appreciated as well as motivated to learn more and more. That's why even if you don't understand just before exam, ping me, but please explain me in the chat. Okay. You cannot call me, but you can ping me in the Teams chat. I can answer if I understand your query. Okay. So need sampling from LLM. So need sampling means that's the first step, right? What we are saying. So you use the LM to produce 4 set of answers, and the 4 set of answers are being ordered by the humans, right? That's the need sampling part. Okay, so we needed that. And RL training process too complicated because of that RM you have to get. See, RM will give you RK, right? And then you have to go back to train the RF to R5, right? So all these things. This is a reward score. So all these are complicated. Is it possible to directly train it? I'm sorry. What pathway? Is it possible to directly train a language model from the human preference annotation, right? So that's what is the point. So because we had the human preference annotations from where we had it in the SFT itself, right? So can we do that? That's where we are coming here. Okay. So in SFT itself, we had some preferences, right? So one is better than other, something like that. You can prefer it and use that to train a model, reward model. So that's what we are doing here. So not reward model, directly LM policy. So what do you do? Currently in the PPO model, if you see, you take the preference model. That's what we discussed, right? So if you go here, what's that? Mm, ah, in PPO, this is the preferences we take from the user, train a RM model, and then train the complete policy like this. Okay. So, but now just I think I should have not come for that small explanation, but okay. So that is what is explained here. You get the preference data from humans, train a reward model, and then you will train a policy model. Okay. But what in DPO what they do? DPO is first and foremost thing is not RL. It's not reinforcement learning at all. Okay. So that's the first thing you should remember. If I ask you to explain 2 reinforcement techniques, please don't include DPO. By default, I have to give 0. Okay. So not 0 means the evaluators will give 0. Okay.
Hello.
Oops. Is it for me?
Not audible for me.
Oh, am I not audible? Oops.
No, no, you are audible. You are audible, sir.
You are audible,
Okay.
sir.
Okay. Okay.
You're audible, sir.
Take it. Okay. Please log out, log in. Okay. Whatever it is. Okay, I have to go fast, 10 minutes. DPO is not RL. Okay, that is the first thing. Second thing is what DPO does is it takes the preference data which you have. Okay, this is one output, this is second output, right? So how did you get the output? You understand, right? So you give a query, you give it to your original LM, right? Original LM means the SFT model, and you got two answers, right? So A and B. In this case, only A and B, because for DPO you require only two. Okay, and then your humans will decide which one goes as a winner. YW means winner, which one goes as a loser. Means it understands that okay, this guy is like equal to 1 and this guy has a score of 0. Okay, so that's the point here. So till here you understood, right? So this is the same as prior. But now what happens from here? You can directly train an LM instead of training an R reward model, which will give you a score, right? That was an extra. So that's what they removed it. So there's a very complicated mathematical thing. If you are interested, you can learn about it if you are doing a PhD on it. Okay, but final thing we will see. Okay. Mm, hmm, correct. This is the final one. Okay. This is the final. So in DPO, what is the loss function? It's a loss function. Okay, it's not a maximization. It's a loss function. What we do is we take phi ref means the original policy model, original LM. They call it as policy model, original LM. Actually, I don't know to speak too much technical. Okay, so I speak in a very layman's language. Sorry if you are too much technical. Okay. Just understand it technically. So this is a reference. This is what is came from LM SFT, which is the second step, right? So this is the same, okay? So phi reference is the, we call it technically as policy model, LM reference, okay? So you are tuning it to, this is the output. This is the output. When you finally fine tuned, it is the output. This you wanted higher, right? Of course, this to be higher, and this minus beta. So from here, this should be higher. Why? Because you are giving a win data, right? So winning data should be higher. This is 1, right? So we saw A belongs to a winning preference. So if you go back and explain, this is a more preferred answer than this is a less preferred answer. Okay, so that is why when you are using W here, it should be higher, right? So this should be 1 will be higher and YL should be lower, and that is what you are just, they have made that equation, the original PPO equation, they have taken the objective and then simplified it. Actually, this is one of the main point. When you read about it, you will understand. Okay, you can go and read about how they killed this reward. So this is the reward model which was there, right? In PPO, we had a reward model. In DPO, we don't have a reward model. So what is the point is, in reward model, in your PPO equation, you can get something like this. And if you can replace this with something, and that's how you can remove that reward model. Once you remove that R term from that, you don't need a reward model. That's what they did. Okay. So using the preference logic. Okay. A simple classification loss model. So you have a winning correct answer. You have a not incorrect answer. It is less correct answer. So that is what the right state terms you should use here. Okay. Winning answer and a losing answer for the same given prompt. Okay. X is the prompt. So that is how this equation came. Okay. So remember again the same. No need to remember. If you understand this equation, you can really write it. Okay. If you see 2 times, 3 times, you can really write it. But I'll surely not ask the equation. Just remember what is the logic and how did we remove the reward model. Okay. So this one is important. How did we remove a reward model? Okay. So just go through that equation. You will easily understand. Okay, so this is just again explanation. DPO eliminates the need to train a reward model. Okay, that's what we have already seen. This is the okay, we'll come here. So DPO training is cheaper. Why? Because you don't need to train a reward model, which I already mentioned. reward model itself is an LM. The original LM itself only considered as reward. So training it is self costly, right? Paisa jayega, right? And it is more stable, right? So cheaper as well as more stable because complexity is not there. Because when you have another LM, see, LM itself hallucinates. You have two LMs to do a particular work, it will hallucinate more, right? So that's as simple as that. So from that only you should answer. So you remove that. But point is you're not doing RL. Keep that in mind. Okay. So DPO, okay. So PPO can handle more informative human feedback because if you remember, we in DPO we had four options. C, D, A is equal to B like this, correct? If you remember. So you can handle more number of options. Like it's not that only these two. In DPO, you had like this, correct? You had a winning answer and losing answer. So you suppose you consider this as one and this is zero. So it's always like this. One is so, but in subjective nature in life, you can never say it's correct or I can. So, like for in your exams also, I will prefer to ask a subjective answer because I want to give you more marks, right? But if I don't like you, for example, I can give you zero. You cannot ask me at all, right? But that is wrong, right? That's not the right way to do it, right? So, in subjective language, the responses, you should never have ones and zeros. It should be like maybe 1.9, 0.8, 0.8, or this is 0, 0, and this is zero point 0.5. So from here, what you understand is this answer is some 50% correct. Okay. So that's what is more informative human feedback, right? Sometimes you can say this answer looks correct, but maybe here and there, like I had one manager long back. So with whatever quality of output you go, he will always give a comment, right? So maybe he feels that that is little more correct. It will be like his tone he will change and then say that this looks more correct. Okay, so not blaming him. That's a very funny stuff we always speak about. So point is that here there is always a scope for improvement. So it again depends on a particular person, right? So that is where subjective answers are always bound to be in either side and all, has a partially correct answer. There's no perfect correct answer or perfect wrong answer. DPO can handle only binary signals. This one you should remember. Okay. These things, why I am in this slide, if you understood, you will come prepared for exam. I don't think that formula slide I was there, so it will be there more. No, it will not come. Okay. It will come with a technical explanation. Okay. Now coming to again the same thing. I think this is the same thing. Okay, so like I will skip this. Challenges with the reward model cannot represent diverse society of human because you have to train RM so much, right? Reward model so much. That's and all the same. That's what basically this paper talks about. What is the challenge in training the reward model? Okay, so you see, and challenges with the policy is again reinforcement learning is difficult, right? So that's why we go for it. That's why we change to this easier stuff. But there is one way, one more way to go about. That's the next thing what we will learn. That is the GRPO. Okay. So in okay, let's see these 2 points. Challenges with the policy. Policy means LM. Okay. So policy means don't think something else. It's a language model. Robust reinforcement is difficult, right? So because you have to keep on trying, lot of input questions you have to give, right? So that's a very input questions and generate the answer. Everything is very difficult, right? High dimensional space because of so much of what do you call the language itself is in a high dimensional space. That's what is right. So that is one thing. Second one is misgeneralization. It depends on the particular training data, right? That is also environment is you can say that the training data what you have used may be different from your deployment data, right? So all these are general disadvantages, but you can this point you can take it as it is difficult because of the uh, language model training itself is difficult because of the size of it. So you can say that. But now coming to this GRP. So GRPO GRPO is first of all RL method. Okay, it's an RL method. BPO is not RL method. This is reinforcement learning. Okay. So now you have a policy model in GRPO also as a policy model. Policy model. So you give a query. This is Q is query and give an output. So let's see PPO, right? So you take a query, give it to your LM. So again, you LM is the SFT LM, right? You take that. It generates an output, right? You send it to your reference model. If you remember, this is your reference model. There is a reward model, right? Reward model is not this. Reward model is RM, right? There is a value model, right? So that is the you have to calculate the value. There is no this one, so you will understand that little later. Okay, so once you get all these things, you get a reward score. So once your reference model, you will get the answer, and the reward model will give you a reference score, and you will get a value here, and then you will calculate the what is this? Can somebody say? Somebody know this?
Autoencoder?
No, no, no. Think of this. Some of the words are already written here. Anybody? Who are from mathematical background? Anybody from mathematical background?
Is it some kind of error calculation?
Ah, correct. What is that error? Already you came up. Just the other two words you can say.
Group aggregation or
Absolute
something.
error.
Group.
What happened? Did I hear anything?
So is it absolute error or
No, no, no. It's not error. It is like estimation actually. So now can you guess the other two words?
I mean, G for
Advantage.
group. G
No,
for group.
group name. Group. Where is the group there? Group is not there, right? There is no group there. So it is like generalization advantage estimation. Okay. So how much it is more advantage than the policy model. So that is what we are calculating here. So so I told you, right? This is the value model. So whenever you get a score like 0.25, you want to compare it. So when I was talking about, you just compare it with 1. Correct. So I told that improve this 0.25 to 1. You remember? That's how we do the training, right? So here, what exactly in PPO they do is they don't compare it with 1. They compare it with what is the maximum possible for the given query and the answer, right? So you cannot target this uh, training this policy model to make this answer to give 1. It's not possible, right? Is it possible? No, it's never. As I said, subjective answers are bound to get any score. You should have some limitation on it. That limitation is this one. Suppose this, if it says value is zero point 0.9, so this 2.25 can maximum reach zero point 0.9. That's the point. Okay, so it's not 1, it is the value, maximum value it can bring. So that is what we are identifying. What is the advantage? Maximum advantage it can go. Estimate that and then get the advantage. So it is 0.25 minus zero point 0.9. Sorry, zero point 0.9 minus 0.25. That is the advantage we are expecting, and then we are fine tuning this. Got it? Okay. Okay, we'll see. You just go through this. If you didn't understand, we'll discuss this again in the next class. Okay. Yes, last thing I'll just tell 2 slides. We'll finish one paper, subject. Next class, I want to discuss some questions also. So here in GRPO, what we do, we'll take the query policy model, generate some few outputs like we generated for our RL, right? Exactly same way, but we are doing it during the training itself. So we had A, B, C, D, right? So like that, you are generating few samples and then we are removing the value model. So value model, what we say here was, this is the maximum what I can expect. Correct. So I say that this is 0.9 means the original score was 0.25. And I'm saying that 0.25, I wanted to increase to 0.9. That's what is my point, right? So maybe 0.7 minus 0.7. So it is 0.25 currently. So I wanted to increase this policy model so that this reward model gives a score of 0.7. That's my aim. Okay. So that's till when I will update the policy model. That's the point what we are discussing here. Okay. So, but in this bottom part, we are removing the value model. Why? Because we don't wanted to say, see, maybe this prediction is also wrong, right? So I'm saying that, okay, maximum you can reach only 70% score. Like in the exam, you are reading, you are eligible to get currently 25 marks, right? So you think that, okay, you study, you can get 70 marks. And you as a teacher, I'm advising you, okay, you if you study, you can get 70 marks easily. Maybe if you study, you can get 90 marks. Or maybe if you study like hell, still you can get only 50 marks. There are options, right? So value model may be wrong, right? So that is where this GRPO came in. What it did was it will have like many examples. Okay, it generated many examples. And then what it will generate one score for each of the questions, each of the outputs. So for each of the output, when you give it to the reward model, query and the output one, sorry, output one, not Q. If you give, it will give R1. Same way, if you give everything, it will give. Okay. And then you will calculate a group computation. Group computation means what it will do, you are trying to push the worst score to a highest score. Suppose you consider RG was the highest. Okay. The last, this one was the highest reward. So you are trying to say the model that this is not good. You push it to this one, higher score. And you push this to higher score. You don't need to push anything, this one. Okay, I'm saying that I have to fine tune this model in such a way that I need this answer to be same quality as this answer. This answer to be same quality as this answer. This answer I am not telling no need to increase because I don't have any other better way to tell this policy model. So here we had a value model. So we told that, okay, 0.7 is the where the you have to reach, right? Here we don't have a value model. So you removed it. You're telling that improve the quality of O1 to OG, improve the quality of O2 to OG, and OG you keep it there only. So in this way, what happens? The policy model you are updating to improve O1 to OG, O2 to OG, and O3 to OG. The overall average quality of output production will improve. Response generation or production. The overall quality, like at the end of the training, it will produce all the outputs with the quality of OG. That is itself sufficient for me. Okay. So why that is sufficient is by the time, so suppose I have first two epochs, I have made sure that O1 and O2 gets generated with the same quality of OG, right? So what happens is by default, even you didn't tell that OG you want to improve, but by default, OG also will improve because you have improved the quality of O1, O2, OG also will improve, right? So it's like you are increasing the average. So by default, OG also will keep going up. It will not go so much high, but it will go somewhat high. That is the intention here. The intention of this complete logic is you are improving the average, you are pushing the lower weak responses towards the best response. And that is sufficient because your overall quality has improved because the average has improved, right? So once the average has improved, by default, the OG also would have improved a little bit, but not like here. PPO is still the best, but PPO is complex and time consuming. So GRPO is easy and it's very, see, if you don't train a value model, you don't want it to get a destination, right? So in that case, you can run like millions of samples here. But here you need a value model. You need a destination, right? Here you don't need a destination. Today you went somewhere. Today you have tomorrow you have to go a little bit better place. That is your destination. So in that case, you don't need this model. So you can train so much, and that's what GRPO came in by DeepSeek. Okay, DeepSeek did this. If you go and read about this GRPO, DeepSeek only introduced this. Okay, so this is the logic they use. So point is, you don't need to. You can keep on training this infinite times, right? So it's like keep on improving the average, keep on improving. So there is always. So you can read about this, read this slide, and then understand the thing. So when to use PPO and when to use GRP? When it is very like very like okay, precise.
Just
I
one
should say.
question. Sorry.
Yeah. Hey,
Just
let me complete. Let me complete, please. I know.
okay.
Then we'll come
Sure.
back to the
Go ahead.
question because let others go. If they may have classes, right? So what I wanted to say is PPO is when you wanted a very precise calculations, always do PPO training. But when you are okay with improving a good quality output, that's fine. You can go for GRP. So if you see here, this is the example. Robotic control task, right? So it's you need a very precise steps, right? You have to pick up something. Your robot has to pick up something, a cap, it has to rotate a cap, or it has to pick up an item from table, right? So you need it to correctly locate that, right? It's with almost precision. So that is why highly effective environments where stability, sample efficiency are very crucial. So you have to take that pain to train it in PPU because that is the ultimate stuff. That quality nobody has till now reached. Okay. Because everything else was, this was fine for a chatbot. For chatbot alignment, this was fine. This was not required for that. Uh, you don't require PPO for chatbot, right? So you can go with uh, overall improvement, right? And you cannot have so many samples. But here you need samples. Of course, you want to make precise decisions. You have to take that pain to train it on PPO. Okay. But here it is not required. Okay, then rest of the things are in English only. You can read. Okay. Just go through till here, and if you didn't understand, let me know. Okay. So parameter efficient tuning is very easy. We go through it in the first half and see some questions in the second half in the next class. Okay. By the time I guess I would have set the question paper also. Okay. Okay. Yeah. Whoever wants to leave can leave. Anybody else wants to discuss can stay. I'm free. I'm a free man. Right?
Yeah.
Free man,
One
eh?
question.
Jobless
Regarding this
man.
GRPO, right? Sorry. So DeepSeek was successful in reducing the GPU need, right? That was their main USP, right? So how this helped in doing that? Like, uh, hello,
Yeah. Just I had
was
a
I audible?
coffee.
Like,
Yeah. I understood your point. Yeah, your
yeah.
question. So how did it reduce the GPU, right? So you don't have a value model, right? So that reduces some part of training resources. So when you reduce one model, it reduces one. See, you have to develop a value model, right? So it's not mentioned earlier. Where there I told that your aim is to bring it to one, correct? But you have to have a value model to bring it to understand what till where you can train, right? That is where you need a value model, but you it has to also parallelly be trained. You understand? So point is, it is not just trained at the starting. This is a training which is parallelly happening along with this training. So that is why during the computation, and as I told you, every model in this is an LM, language model by itself. You understood,
Okay.
right? So these two trainings you are doing parallelly, but here you are doing only one training.
Okay.
You're not worried about the destination. You are worried about, okay, keeping better every step I take, I'm improving O1 towards OG, O2 towards OG, which is also my own output. The policy is output only, OG also. Only thing is, I have 5 outputs and I feel that, okay, first 4 outputs can be improved towards the fifth one. So point is, while I'm changing my weights to make sure, while I'm changing my knowledge to always produce my answers in the same quality as the fifth one, by default, my overall quality has improved, right? Average. So by default, my model has improved better. You understand?
Okay.
But if you, in this logic, if you see, you cannot do GRPO without doing SFT. You agree this or not? This is an implied answer.
Yeah. Okay.
Correct. You
Yeah.
cannot do GRPO, but you can do PPO without doing SFT. This is knowledge, but I will not ask in exam. But this is a really, if you understand both the all three techniques, SFT, PPO, and GRPO, you will accept that PPO you can do without SFT, but GRPO you can never do without CF because it has to because GRPO is dependent on its own best answer. So policy should be able to provide some good answers at least. Okay, so SFT will help you in that. You cannot directly come to GRPO. Maybe you can do directly PPO a little bit and then come to GRPO, but GRPO requires some amount of SFT. But PPO
So
you
can you
may
say
skip.
like initial answers of PPO will be better in GRPO, but as if you have multiple iterations, GRPO will match PPO with the with the
GRPO,
reduced computation. Like,
no.
oh,
PPO is a high quality. Why? Because you are having everything based on human preference, right? PPO, you
okay.
have humans there. But in GRPO, where is humans? Humans are not there, you see. Humans
Yeah.
are not at all required, right?
Yes.
Only in the reward model you require, but value model is not required, right? So in that case, you save lot of money, but you are not, what do you say? You are not, what I was talking about. You are not reaching that better accuracy. So in this one, you have a value model to push you up and up, right? Here, once this is set up, the policy model's best answer is the maximum best GRPO can bring in. It is more like self-learning, right? Something like that. So I am trying to make sure I give all the outputs as the my one of the best outputs, right? The best, they'll say, right? I'll give my best. That's what. But when you have a mentor, the best also will improve. So PPO is like having a mentor, right? So your best is there, but your mentor will give you a or your best also he will try to improve it, right? That's what is the value model. It's like having a mentor. Here you don't have a mentor. You yourself, okay, you may sometimes make a bad decision, sometimes good decision. The only thing is you are ensuring doing GRPO, you're ensuring that all the decisions you will take the best good decision as per your own knowledge. So that's what is here. Okay.
Okay.
So, sir, in PPO, even the score assigned by value model, is it also like mediated by humans from human feedback?
This one, this
Yeah,
one.
value model, value model. The
No,
point.
not this value model. Reward model is
Okay.
trained by humans.
Then what is the
Value
basis
model
for?
is getting trained during this process.
Okay.
Okay. It starts from a very high score and it will tell you maximum where it can reach. You understand?
Yeah.
Hmm. Because one is not possible. That's what I told you in before. I told one is the aim, but that is not possible, right? You have to decrease that value model to in a way that okay, you can stop it at some point. Otherwise, It'll keep on thinking of one only and it will go infinite times. PPO is the best training, but point is it is very robust and it requires more of this computation, policy model and both are LM, both are language model actually. This is also SFT only. Mhm. Just that the output is different from this output. This is a text output, this is a score output. And reward model is also an LM only. Correct. So it is also giving a score R. Okay.
Okay, thank you.
Any other questions? What is the basis of value model to assign a score? Right?
I got the answer. You
Okay.
already
You
answered.
only asked. Okay.
Yeah.
Okay. Any other questions? This is regarding assignment. We have peer feedback review feedback slide in the assignment. Whom should we ask to give feedback? Is it within the group? No, no, it is not within. I told this answer last class. It is not within the group. You can ask anybody in your batch who is taking, even according to me, no, I will not tell that word unnecessarily. It consider those who are in the conversational AI course, but it can be from any section, any other group, any doesn't see in this assignment there is nothing related to your group. Okay, you are an individual person. Okay, that's the point. You can meet your group members because you already have some good friendship with them. That's why they may be in your group. But one condition was there that they should not, the person who is giving you the feedback should not have the same paper as you. Okay. So ideally, I will not check it, but please ensure at your end. Okay. Topic mapping value is different in submitted assignment as I did not realize it was part of the huh? Topic mapping value is different in submitted assignment. Not realized. Topic mapping value, matlab kya hai? What is it? Is it okay? Mail says
Sir, first
L2.
slide. In first slide, it is asking for the topic mapping also. Author name, published year, and topic
Okay.
map.
Okay. So you didn't fill that in your PPT. That's what you're
Yeah,
saying.
yeah. Yes, yes.
I think now you can fill it, right? You have time more. You can
I
fill it
already
and resubmit it.
I submitted
Is it?
once. It won't allow. It's not allowing resubmission.
Actually, yeah. Oh, maybe I didn't open it. I'll check. I'll check with that thing. I can open multiple times till the end of the um, time. You can submit multiple times. I'll check and I'll open it for more times. You can
Yeah.
check after some time. Okay.
Because I found the reference in lecturer 4 rather than lecturer 3. So I entered lecturer 4.
Okay. That is not a problem. Don't worry of that much. That is for your justification only. Even if you don't revise this, doesn't matter. Content in the slide should be related to your technical paper. That is the major thing what I will see because this and all is too much minor, right? In fact, we taught lecture 3 for lecture 4 for 2 lectures, right? Or I think lecture 2 for 2 lectures, whatever it is. So that and all I am not see. As I told you, target is to give you guys 10. Only if you have not done it or done it very poorly, or I hate people who are very irresponsible, right? So I'll not say irresponsible, that's not the right word. They themselves call they're very busy with their office work that they could not spend time. But that's a lie we tell ourselves, right? So I feel it like that. So to be truthful to that lie, whoever tells that should go to their own life and review from morning to night what they do and really they could not find time or not until they have some physical or medical problems. It's impossible they could not find correct time and do properly. So those we are really, I hate that only. Otherwise, everybody deserves 10. If you are putting, I'll not ask 16 into 2. If you have put in around uh, 8 lectures, right? So for mid exam, if you have put around 8 into 2, 16 plus 2. 2. Okay. 32 hours total. 32 hours is too much even. If you, but I consider all the things what you learned related to this also into that. I put in 32 hours because I read, even after I go through the lectures, I go watch YouTube videos, other things. It's just that different perspectives I always watch. Reading books is one of the last thing I do, but but still I go through some of the books also, papers, not books. So those just as I do. The only thing is, if you have done average amount of hard work, you will get it. That lie what I always hear is that they don't get time because office work ज़्यादा है, deployment है, production में जा रहा है. This and all fine, but then you have wasted your money, right? So it's a lie I tell, but it may be harsh, but it's a lie you tell yourself that you have wasted your 80 or whatever is the money, thousands of money, what you have invested for this semester, right? So that nobody is going to worry, right? That's I'm not telling to you, sorry, you are unmuted, but I was talking to everyone in that case. Okay. Any other points? Anything anybody wants to discuss? All good. Everything you learned this class is something useful. Lot of things I spoke too much, 2 hours. Any feedback? Bad feedback, good feedback? Anything to improve? No problem. If you're angry at me, you can also tell. I will stop the recording so that others will not hear this useless talks. Yeah, I stop the recording.